of those who are not able to attend. Our plan for this week, for today and for Thursday, is really to review for the final exam. I will tell you the final exam is basically 10 different hypothesis tests, okay, because it covers only the content of modules 3 and 4. And quite honestly, since really midterm, we have been focusing our attention on hypothesis testing in some format. And so a couple of things I want to point out, and then we'll get into the questions. One is, remember that you can earn 5 bonus points by completing your course evaluation. You should have gotten an email in your Georgia Highlands College student email account, not within D2L, with a link that is unique to you for, and it should be the Stat 2401 course evaluation. So you have until next Monday to complete that. You can earn 5 bonus points. Also, the announcement for this week is related to the final exam review. The final exam review is not really a graded assignment, or in the past has not been a graded assignment. And so I encourage students to complete it by offering 10 bonus points. So you can do that. It is within D2L. Also attached to the announcement about the final exam is just some information about the test itself. And I already have the document opened up. So I was going to share, I guess it would help if I share my screen, huh? Y'all let me forget. Okay, so in the course, remember that you have the opportunity to do your course evaluation. Again, it comes to your Georgia Highlands College student email. And then you have information about the final exam review. And there's an attachment that gives you some just general information about the final exam. And it is not, the final exam for Stat 2401 is not proctored. So you can use any of your handwritten notes, the flow charts, the PowerPoints, practice problems, you know, any of the notes that you've taken during the course. You will need to access Minitab during the final exam. The final exam is scheduled to open Monday, December the 5th. It'll open at midnight, and it will close on Saturday, December the 10th at 11:30. I have it set to allow you 3 hours to take the final exam. However, if it takes you longer, you're not going to be cut off at the 3-hour mark, okay? Because I know entering the data takes time and stuff like that. If it takes longer, it's fine. You're not going to get cut off. I simply get a notification that you took longer than the time allotted. It's not a problem. There is only one attempt on the final exam, and there are no makeups. It is primarily multiple choice and fill in the blank, much like the midterm. I would encourage you to just be careful, read carefully, pay attention to how it asks you to round and that kind of thing. I will, however, be reviewing your submission so that if if it says to round to 2 places and you round to 1, or you forget to round or whatever, then I will, make the adjustments. It does only focus on modules 3 and 4. And again, it is pretty much all hypothesis testing. And so I've given you a breakdown of each section. And the sections, I even tell you what that topic is. So you might want to have this document so that if you don't remember, you'll kind of know what the topic is. There are 75 questions, so they're 2 points apiece for a total of 150 points. So do you have any general questions related to the final exam, kind of the expectations, what's going to occur, that kind of thing? You do have to take it in one sitting, so you'll need to allot, that 2 to 4 hour window of time to take it sometime between the 5th of December and December the 10th. Any questions? Again, that document that you're viewing is attached to the announcement, so you can open it up. The other document that I might encourage you to have nearby as you're looking at preparing for the exam is, I believe I posted it several weeks back in the announcements about which test should you use, especially since we've been talking about all these different kinds of hypothesis tests. We talked about both parametric and non-parametric, and so you're going to have to make a decision based on reading the problem which scenario you have. You know, do you do a one mean z, a one mean t? Is it a one proportion, two proportion? Is it a chi-square? And so this particular document, which again I posted back several weeks in the announcements, kind of outlines for you when you use a specific type of distribution. It gives you both parametric and non-parametric. I will tell you that for the purposes of the final, our focus is on parametric, because again, as we've talked about throughout the semester, parametric tests are technically more powerful. The results are more reliable than the non-parametric, but non-parametric has a place if, especially if you know that your data is not normally distributed, or if it's skewed left or skewed right, or has some kind of weird distribution. So you may want to, if you haven't already, print off that document. Hopefully you've kept your notes, and they're organized again by topics. You know, if you want to go through your notebook and like tag them with a little post-it note or something to indicate that this is one mean z, one mean t, so you can go back to that. If you have forgotten some of the commands for Minitab, I do have, I believe, in each lesson, I have the folder in D2L labeled Minitab instructions. So, and they're sorted by module, so you'll be focusing on module 3 and module 4. So they're broken down by topics there. So you do have access to that information as well in case you've forgotten those keystrokes. I know if it's not a test that we do routinely, it might not be one that you remember. So any questions on that? That's just some resources that you already have that you may want to refer back to. So I'd like to dive into the actual Stat 2401 review. Again, it's in D2L, and I've pulled the information into Word for us to look at. One of the things that I personally would encourage you to do is to read the scenario, maybe read through the questions, because they might give you a clue about, you know, how to work the problem, what test you're doing, that kind of thing. But I would actually tell you just to work through the problem first, kind of like we do together in class, and then go back to the document in D2L and answer the questions. Because if you've written the problem out, as we've done in class throughout our discussions, then you're going to have everything you need, and it's just a matter of transferring the information from your paper to D2L. But again, that would be my approach, but you may choose how to do that. So scenario 1 says, using the following Minitab data to answer the following questions about the test for normality. So one of the things that I'll notice in this question here, guys, is that it tells me that I'm doing a test for normality. Okay, so reading the instructions carefully, you know, word for word, not just kind of skimping or skimming over it, may give you a clue. It says download the data set and run a normality test and use a 0.05 level of significance. And then in the questions itself, it talks about using the debt variable, the variable debt. So I'm going to try to click on this link, maybe. I may have to go out. Whoops, I don't want to draw. I may have to go out to Minitab to do it, or into the course to do it. Okay, so I would click on this data set, and it's about loans, and I have to download it, but it's a Minitab file. So I'm just going to download it, but I'm not going to try to open it. We've been doing this all semester long. I'm going to save it. I'm not going to try to open it, but then I go into Minitab and I want to open the worksheet, and I can pull that data. Well, maybe. And it was loan applicant. And we have 8 different variables in this data set: income, education, age, residence, employee, savings, and debt, and credit cards. Again, the questions, if you look at it in D2L, let me go back to the quiz. It says, what is the Anderson-Darling value for normality of the variable debt? So again, my focus is on the variable debt. But I'm going to come back over here to my document. And again, the instructions have told me I'm doing a test for normality. So if we go back and we think about the first step in the hypothesis test is to state the hypotheses. And we need to state the null, and we need to state the alternative. And so we're doing a test for normality. So we would say that debt, the debt variable, because that's the one it told us to focus on, the debt follows a normal distribution. Remember, the idea here of it follows gives us that sense that it's equal. And then my alternative would be that the debt does not follow a normal distribution. And again, that gives us a sense that it is not equal. So we're not breaking any of the rules or guidelines related to stating the hypothesis. Step 2 in the process, of course, is to identify the necessary information. In this particular case, we have the raw data. Okay, so we have the raw data that's given to us in the data set, and we need the alpha, or the level of significance. And I believe, I'll go back and double check, but I believe it told us to use a 0.05 level of significance. It did. Okay, so there's my players. Step 3 in the process is to calculate the test statistic, which for this problem would be Anderson-Darling, and its p-value. Now again, if you have forgotten how to do those keystrokes in Minitab, you can find those in D2L. But if I remember correctly, we go to Stat, Basic Statistics, Normality Test. Stat, Basic Statistics, Normality Test. The variable that we're interested in is debt. We're not worried about percentile lines, and we are calculating Anderson-Darling. And I click OK. And remember that we get this plot, and I'm going to copy it over to our paper. Okay, so we get this plot, and the pieces that we need the Anderson-Darling test statistic and the p-value, which are located kind of in the margin on the right-hand side of that probability plot. So my Anderson-Darling, based on this graph, is 3.211, and the p-value, it says it's less than 0.005. Okay, so it says less than. We'll just use it as equal because that's what we have. Okay, so we pull that information from the table. Then step 4 in the hypothesis testing process is to make a decision. We make our decision by comparing the p-value from Minitab to the level of significance. So we have p-value was 0.005. The level of significance was 0.05. Remember, we do that comparison digit for digit. So we have 0 to 0, 0 to 5. 0 is less than 5. So the p-value is less than or equal to the level of significance. When the p-value is less than or equal to the level of significance, we reject the null. Okay. And then step 5 in any hypothesis test is to state or write the conclusion. Now remember, for normality, the conclusion was written just a little bit differently from the others because it says preliminary analysis shows that the variable debt does not follow a normal distribution. Now, to make sure you understand why I wrote it that way, let's go back up here to our hypotheses. We determined that we were going to reject the null. If we reject the null, that means the null is false and the alternative is true. So that indicates, if the alternative is true, that it does not follow a normal distribution. Now, when you're looking at this document in D2L, I may not have it worded exactly the same as it is in D2L, but guys, we're close enough. Okay. See, they say preliminary analysis showed the data set for average debt is not normally distributed as assessed by Anderson-Darling. Okay, so again, we needed the one that said not normally distributed. It's important, guys, you need to read it word for word. Don't just skim because you'll miss it. So I would mark, in this case, the top one. Okay, so our wording may be slightly different. I did not write the questions on the final exam. Okay, so they may be worded slightly differently, but you should still be able to kind of figure it out pretty easily. So questions on scenario 1. Hopefully you're taking notes. The questions on the review are in the same order that you will see on the final. So question 1 here is normality. So question 1 on the final exam should be normality. Now you may want to double check me on that, but I don't usually try to trip you up. Okay, scenario 2. A survey claims that the average cost of a hotel room in Atlanta is $69.23. To test this claim, a researcher selects a sample of 30 hotel rooms and finds the average cost is $68.43. Assume the population standard deviation of $3.72. At a 0.05 significance level, is there enough evidence to reject the claim that the average cost of a hotel room in Atlanta is $69.23? So again, one of the first things you have to make a decision about here is to decide which scenario you have. Is it, a one mean T, a one mean Z, a one proportion? What kind is it? A couple of things stand out to me. One, it says test the claim that the average, so it talks about average, which is another word for the mean. I also notice that in the middle of this problem, it says assume the population standard deviation of $3.72. Okay, and I only have one measurement. It's talking about the average cost, and it's talking about average. So that would mean I have a one mean z-test. I know I'm going to do z because we know the population standard deviation. Okay, so this is a one mean z-test. We begin the process the same way we begin any hypothesis test. We begin by stating the hypotheses. And again, I think it's easier to work through the problem without trying to focus on the questions first. Go through your hypothesis testing process. Okay, so the last sentence says test the claim that the average cost of a hotel room in Atlanta is. So I see the word is, and mathematically the word is makes me think of equal. So that means that statement is the null, because remember, the null hypothesis always and forever contains equal in some form. So writing it in the symbols, we would say the mean is $69.23. And I'm just going to indicate that that was the one given. And the alternative would be the exact opposite. The opposite of equal is not equal. Now, I don't think it's on the document. Let me see. When this tells you which test to use, it doesn't indicate here what information do you need. So hopefully you may have that in your notes, because remember, step 2 here is to identify the information that you need. Now remember, I pretty much teach this almost every semester, every day. So I remember you have to have the population mean, the population standard deviation, the sample mean, the sample size, and your level of significance. The population mean comes from your hypothesis, so that's $69.23. The population standard deviation I've highlighted in green in the scenario, so that's $3.72. If I back up one sentence, it says, to test the claim, a researcher selects a sample of 30 hotel rooms and finds the average cost is $68.43. So that tells me that my sample mean is $68.43, and she checked 30 rooms. And my level of significance is 0.05. It says at the 0.05 level of significance. Okay, so we have all of our information. Everything we need to work the problem is given in the scenario. So then step 3 is we're going to calculate the test statistic. And for this problem, it's going to be a Z and its p-value. And again, we do that in Minitab. And again, if you have forgotten the keystrokes, I anticipate you having them written down in your notes, but if they're not, they're available in D2L. So here we go. Stat, basic statistics, one sample Z. We have summarized data. My sample size is 30. The sample mean was $68.43. The known population standard deviation was $3.72. We are performing a hypothesis test, excuse me. The hypothesized mean is $69.23. We go to options. We're using a level of significance of 0.05. So the confidence level is 95. And we were doing not equal. So I don't have to change that. So I click OK and OK again. So hopefully that process maybe seems familiar. Then we scroll down under the header test, and it gives us our p-value and our Z. And I'm going to have to put it down here. Okay, so from this table, we see our Z value and our p-value. So I can see that Z is negative 1.18 and my p-value is 0.239. Question 4 then, we're going to, or the next step, excuse me, is to make a decision. We compare the p-value to the level of significance. So I have 0.239 compared to 0.05, comparing digit for digit. 2 compared to 0. 2 is less, or excuse me, 2 is greater. Woo, about messed that up. 2 is greater than 0. So P is greater than the level of significance. When P is greater than the level of significance, we fail to reject the null, which then that takes us to the last step where we need to write our conclusion. So it would be at the 0.05 level of significance. Let's go back up here to the question to make sure we get it right. Okay, we decided that we fail to reject the null, which means the null hypothesis is true and the alternative is false. So based on the evidence that we have proven that the average cost of a hotel room in Atlanta is $69.23. So that's what we're going to say in our conclusion. At the 0.05 level of significance, the average cost of a hotel room in Atlanta is $69.23. Questions? Am I going too fast? All right, scenario 3. A researcher reads that the marital status of U.S. adults is distributed as follows: never married 30%, married 56%, widowed 3%, and divorced 11%. He selects a sample of 400 people, and the results are shown below. At the 0.05 level of significance, can it be concluded that the marital status of U.S. adults is as she has read or as stated? Okay, so again, you have to kind of try to determine what scenario you have here. One of the first things that I notice is talking about the marital status, and the marital status involves words, which means I'm dealing with qualitative data. There's only a few tests that we looked at that deal with qualitative data. Primarily, it's the 3 last ones: chi-square, goodness of fit, chi-square test of independence, or chi-square test of homogeneity. Okay, so I'm pretty sure that this is probably one of those chi-square tests, but I need to decide which one. And we're trying to decide if we basically, if the marital status is the same as she's read, does it fit? Does it follow the distribution? So this is actually chi-square goodness of fit. Let's go over to our document about which distribution to use. Okay, chi-square, you have qualitative data, no words or phrases, and it's a single survey question. So the survey question, if you kind of read between the lines here, would have been, what is your marital status? So that's one question. And the question usually says, does the distribution fit, follow, match a known distribution? To do test of independence or test of homogeneity, you have to have two variables or two factors. And so since we only have one, and that pretty much defaults us to goodness of fit. Again, we begin the process, and I know y'all get tired of hearing me say this, but the first step is to state the hypotheses. So remember, with chi-square goodness of fit, the null will always in some way imply equal, and the alternative will imply not equal. We don't have to worry about greater than, less than, and so forth. So again, the idea that it's equal would be that it fits or follows the distribution as stated. So we would say the marital status follows the given or the stated distribution. Now, you could write that out, and I want to show you because I happen to know, since I looked at it earlier this morning, that if you look at the way it's worded in D2L, and let me scroll down to scenario 3, it does list it out. So it says the marital status of U.S. adults fits the given distribution, and it writes out what that distribution is. The important piece here, guys, is that for the null, it needs to fit or equal the distribution, and for the alternative, it does not. Okay, so I use the phrase the marital status follows. Okay, so it's the same concept. The alternative would be that the marital status does not follow the given or the stated distribution. Step 2 is to identify the needed information. So I'm going to write that up here because the needed information is the table that you're given. So you need this table. We also need our level of significance, or alpha, which is 0.05. And we need the distribution that is given. So we need to know these percentages. Can actually add another column to that table. Okay, so let me write down those percentages real quick because I didn't do that earlier. 56. I would encourage you to be extra careful as you're writing the information down to transfer it from D2L to the mini tab. Okay, just be extra careful, make sure you write it down. So step 3 is to calculate the test statistic, which we decided for this problem is chi-square goodness of fit, and its p-value. So we go out to Minitab and we basically have to recreate the table that we're given. So in column 1, I would put marital status. In column 2, I would put the observed count. How many did the researcher find when they surveyed those 400 people? And then we have the expected percentage. And again, remember, you put that expected percentage in the form of a decimal. The expected percentage goes in as a decimal. So I have never married, widowed, divorced. And let me see, I wrote down the numbers. So never married was 150. Again, double check, make sure you put the numbers in correctly. 228 married, 5 were widowed, and 17 divorced. The percentages stated in the research were 30% had never married, 50% had married, 3% were widowed, and 11% divorced. So that I basically have recreated and added a column to the given table. Okay, so I have all my data entered into Minitab. Then we go Stat, Tables, Chi-square goodness of fit test. My observed counts are in column 2. My category names are in column 1. And we're doing proportions specified by historical counts. That's the expected. So you choose where are the observed counts, where are your category names, the words, and then proportions specified by historical counts. And I click OK. Again, remember, we get lots of information. We did talk about, should you need it, you do have the expected values for each category. Minitab calculates those for you. But what we need is the chi-square test. And I can read from my printout the chi-square value and its corresponding p-value. So my test statistic, my sorry about that. Forgot to change back to my pen. My chi-square goodness of fit test statistic is 28.2229, and my corresponding p-value is 0.000, which for all, is really just plain old 0. But again, depending on how many decimal places you may be asked for. Step 4 is we make a decision. We make the decision by comparing the p-value to the level of significance. So I have 0.000 compared to 0.05. Again, we compare digit for digit. So 0 compared to 0, 0 compared to 5, 0 is less than 5, so the p-value is less than or equal to the level of significance. When the p-value is less than or equal to the level of significance, we reject the null. So in the context of this problem, If we reject the null, that means the null is false and the alternative is true. So based on the data we have, the marital status does not follow that given or stated distribution. So step 5 is to write the conclusion. And make a little bit of space here. So we would say at the 0.05 level of significance, marital status does not follow the given or stated distribution. And again, you could write out what that distribution is. You know, we could say, what was it? 30% never married, 50% married, 3% widowed, and 11% divorced. Again, we've talked about it before, and the details are important. Okay, but if you're trying to work through the test, you know, you could kind of shortcut it and not put in all the details, assuming that then when you go over here to D2L and you get down here to the conclusion, you realize, oh, it's got all the details in there. Questions? All right, let's look at scenario 4. Scenario 4 says, suppose a group is interested in determining whether teenagers obtain their driver's license at approximately the same average age across the country. Suppose that the following data are randomly collected from 5, it should say, yeah, should say 4, from 4 teenagers in each region of the country. The numbers represent the age at which teenagers obtained their driver's license. Use a level of significance of 0.10. And so we have data, we have the age at which they got their driver's license. So we have age, which is quantitative. And notice it's one variable, but it's been divided into groups. So it's sorted by region, which part of the country they're from. So what this triggers in my mind is analysis of variance. And again, you can go over to your document and let's see if we can find one-way analysis. You have quantitative data, numbers, sorted into groups using words. Okay, so again, think about what we have here. We have age sorted by region, and region is words. So this is Anova. So then we get ready to do our hypotheses. Step 1, state the hypotheses. Again, with Anova, the focus is on it being equal and not equal. We don't worry about greater than, less than, and so forth. So we're saying that the mean age to obtain a driver's license is the same for each region. Okay, the mean age is the same for each region. The alternative then would be that at least one mean age is different. Or you could say the mean age to obtain a driver's license is not the same. But I think, again, I'm trying to use the similar language to what you're going to see in D2L, because I kind of looked ahead to see. So again, if we look ahead a little bit, they use the phrase, the mean ages are approximately the same. And then the alternative, at least one, is different. Okay, so I'm trying to use similar language again because I had looked ahead. So this kind of gives you a heads up. This is what you might be looking for, kind of deal. Step 2, as we noted just a few minutes ago, step 2 here is to identify the players, and our players is this table of information. So step 2 is where you identify the information. The information for the Anova is given in this table form. The other piece we need is our level of significance, which we're told in the last sentence to use a level of significance of 0.10, 0.10. Then step 3, we calculate the test statistic, for Anova. Remember, that's the F, and its p-value. So we need to enter the data. We pretty much have to recreate that table that was given in the problem in Minitab. Now, guys, you have a couple of options here when you do this. We've already used columns 1, 2, and 3. So I could go over and maybe use 5, 6, 7, and 8. That's fine. Or remember, you can always get yourself a new worksheet. You can get a new blank one and enter the data there. You can do it either way. It doesn't matter. So we're going to have northeast, south, and I misspelled that, sorry, west, and east. And then we enter the data from each column. Make sure you keep them under the same header. Whoops. Make sure you enter them correctly. Okay, so you have to enter the data. Again, basically, I've recreated that table that was given to us in the problem. All right. Again, if you don't remember the keystrokes, you can find those in D2L under the Minitab instructions folder. But we go Stat, Anova, One Way. Stat, Anova, One Way. Our data is in separate columns. I have to choose all of the columns where the data is located. I believe we have to go to options. We want to assume equal variances. Our confidence level, because we're doing a 0.10 or 10, our confidence level is only 90%, and it's two-sided. Click OK. Click OK. We scroll down till we find the analysis of variance table. That gives us all of our lovely data. And we enter it. Okay. Again, the table gives us the information we need. It gives us the F value and the corresponding P value. And we write those down. I just think writing it down first makes it easier when I go to try to answer the questions. So I have F equals 2.39 and my P value is 0.120. So then we go to step 4, where we make a decision. We're going to compare the p-value to our level of significance. So my p-value is 0.120. My level of significance is 0.10. So I'm going to make the comparison. Again, do it digit for digit. So 1 compared to 1, 2 compared to 0. 2 is greater than 0, so P is greater than the level of significance. When P is greater than the level of significance, we fail to reject the null. If we fail to reject the null, go back and look at our hypotheses. If we fail to reject the null, that means the null is true and the alternative is false. So based on the information that we have, the mean age to obtain a driver's license is the same for each region. So our last step, as always, is to write the conclusion. We would say at the 0.10 level of significance, the mean age at which teenagers get a driver's license is the same for each region. Questions? All right, let's see if we can get through scenario 5, and that puts us about halfway through the document. Okay, so scenario 5 reads, Miss Ralston is concerned that the 2 sections of elementary statistics that she teaches are not performing at the same level. To test her claim, she looks at the second exam average from a random sample of her classes. In class 1, the exam average of 26 students is 85.69 with a standard deviation of 10.78. In class 2, the exam average of 27 students is 87.59 with a standard deviation of 8.93. Test Ms. Ralston's claim that class 1 and class 2 are not performing equally at the 0.05 level of significance. Class 1 is sample 1 and class 2 is sample 2. So again, a couple of things jump out at me here. First is talking about two sections, two things, two groups. Then it says something about average. They're not performing equally. So when I see kind of that scenario, okay, I'm thinking it's got to be two mean, and the only two mean tests we do is T or paired T. I believe this is the one that is for independent. They're not paired together. Remember, paired together is like a before and after. This is two totally separate groups. And again, you can see that if we go back up here and look, two mean hypothesis tests, you have numbers. We use a t-test if we don't know the population standard deviation, and we don't. Independent groups compares two different samples, and then matched pairs compares one sample at two different points in time. We're comparing two totally different groups because we talk about group 1 and group 2, or class 1, class 2. So again, our first step is to state the hypotheses. And near the end of the problem, it says to us, test Ms. Ralston's claim that class 1 and class 2 are not performing equally. Okay, so the words are spread apart, but it says not, not equally, which makes me think of the not equal symbol, which means that statement is the alternative. So we're saying that the mean for class 1 does not equal the mean for class 2. That's the given. The null will then be the exact opposite, which would be that they are equal. So the mean for class 1 is equal to the mean for class 2. Now again, for step 2, where you have to identify the players, you may not remember everything that you need, but you have to have information related to class 1 or sample 1 and the same information related to class 2. And we need the sample mean, the sample size, and the standard deviation. Okay, so for class 1, it says in about the third sentence, in class 1, the exam average, of 26 students is 85.69 with a standard deviation of 10.78. So we have a mean of 85.69 for 26 students and a standard deviation of 10.78. If I continue reading, in class 2, the exam average of 27 students is 87.59. So for class 2, my average is 87.59. We had 27 students, and what did it say the standard deviation was? And the standard deviation is 8.93. So it may help you, to organize the data into a table. We also need the level of significance, which is alpha equals 0.05. Step 3 is to calculate the test statistic, which for this problem is a t, and its p-value. We use Minitab to do that. Okay, so I'm going out to Minitab. We go to Stat, Basic Statistics. This is a 2-sample T. I have summarized data. The sample size, let me see, I need to scribble that down because I forgot to do that. Whoops, where did it go? Okay, so for class 1, let me write it down real quick. Okay, so for my sample size for sample 1 was 26. That's given in the problem. The sample mean was 85.69, given in the problem. And the standard deviation was 10.78, given in the problem. Sample 2, there were 27 in the group, and the average was 87.59. Oops. And the standard deviation was 8.93. So all of this information, the summarized data, I got from the problem. We go to options. We're using alpha equals 0.05, so it is a 95% confidence interval. Our hypothesized difference is 0. And our difference in this case was not equal, and we are assuming equal variances. Click OK. Click OK. And again, we get lots of different stuff, remember, but what we need is this test. Okay, copy. Okay, from the test that we conducted, we get our t-value and our p-value. It's given in that printout. So we record it. So my t-test statistic is negative 0.70. My p-value is 0.487. I know it's 12:15, guys. I got 2 steps left. If you can hang with me for just a minute, let me finish this out. Step 4 is to make a decision. So we're going to compare the p-value to the alpha. So 0.487 2.05. Again, remember to do it digit for digit. 4 is greater than 0, so P is greater than alpha. When P is greater than alpha, we fail to reject the null. If we fail to reject the null, the null is true and the alternative is false. So based on the evidence, Miss Ralston's claim is incorrect because class 1 and class 2 are performing equally. So we would write our conclusion. That's the last step. At the 0.05 level of significance, class 1 and class 2 are performing equally. Now, I apologize. I've kind of kept you over 2 minutes. I'm sorry, but I wanted to finish that problem out. That gets us halfway through the review sheet. So we will hopefully finish that up on Thursday, and you'll maybe have everything organized and be ready to take the final exam. Any last minute questions? I'm sorry for keeping you over. All right, guys, y'all have a good afternoon. I'll see you Thursday.
Have a good afternoon. Bye.
Good afternoon.